All right, so good morning, everyone. Hope you're all staying warm with this cold blast coming across the states. For those of you who don't know, my name is Zach Nicklin. I'm a co-PI for the National Center for Autonomous Technology. I'm also the program manager for Northland Community and Technical College's UAS programs. So welcome today in our Think Autonomous series, where we talk about relative or relevant topics to what's going on and in autonomous technologies, new and emerging technologies. And today we got a little bit of focus on the aviation side of the house. So with me, I've got two folks here. I've got Tracy Yother from Purdue, and I've got Stephen Lay from Utah Valley University. If you, Tracy, you want to take a second, just tell us who you are and what you do.
Sure. My name is Tracy Yother, as Zach said. I am an assistant professor at Purdue University in the Aeronautical Engineering Technology program. That's essentially our Part 147 airframe and power plant program with a little bit extra on top to get a engineering technology program. I am the newbie on this program. I've been a professor for all of 2.5 years now and learning. And so Zach and Stephen and I have been working on some standards. I've also been working and have a grant through NIST for curriculum development on standards. So yeah, that's me.
All right, thanks a lot. Welcome, Tracy. Stephen, you want to give us a synopsis of who you are and what you do?
Yeah, I'll try not to be too much of a professor, and I'll try to keep it as short as possible. My name is Stephen Lay. I'm an associate professor at Utah Valley University. I've been with UVU since about summer of 2016. I am an A&P mechanic. I've had my inspection authorization, and also I had my designated maintenance examiner certificate way back when. We're in the process right now at UVU developing an FAR Part 147 airframe and power plant maintenance technician program. And we're also very, very involved in the state of Utah in developing the infrastructure to support advanced air mobility. This includes a variety of different aircraft, all the way from UAS to electric aircraft to eVTOL airplanes. And we're very, very keen to try to help facilitate at a local level and also at a national level of developing technician standards for EV aircraft. Through our investigation of electric vehicles on the automotive side, we found a lot of commonality that transfers over to EV aircraft. So we're very, very excited at the opportunity to be able to collaborate with a variety of different groups across the nation to be able to pull in their expertise and work together to come up with a set of EV technician standards that we can actually use, hopefully immediately, and also make recommendations to the Federal Aviation Administration. So we're very, very excited about having this opportunity. And we want to thank Zach and NCAT for sponsoring this webinar and engaging the community in these topics.
Absolutely. And again, thank you for joining us here, Stephen. So let's start digging in a little bit to the meat of it. As educators, a lot of our focus really is workforce needs, right? As we start programs, as we start looking at curriculums and what standards we're adopting, it's kind of all about the workforce needs. And I'm at a 2-year community college, so it's very regionally focused. NCAT though has kind of a mandate throughout the nation, and I know Tracy and Stephen, you've got a lot of those same requirements to meet of addressing the workforce needs, because we fully understand that a degree without a job prospect is not very valuable to folks. So as we look, we get the Boeing jobs report that comes out every year with that 20-year focus, and it's talking about 600,000 aerospace technicians, and I believe that number is worldwide, and so it's a little less when we just focus on the United States, but it's still a very significant number. And then as we're talking about this, and we talk about 147 technicians, and we'd like to thank the FAA. The FAA actually, with the new Part 147, has introduced some exciting stuff and some new ways to do business. But so what are your thoughts and feelings when it comes to the new and emerging technologies and where the ACS kind of and the Part 147 kind of fits into there?
I'm gonna start because I know Stephen's gonna come in after me and have a lot more to say. And think of all those things I didn't say. Look, you're absolutely right. We've got 600,000 of a shortage of technicians, and that's just what we know about today with the technologies and stuff. These are, traditional airplanes that are, turbines or reciprocating engines. They're not thinking about electric propulsion and how that fits into everything else. Unmanned is another area, air mobility. Those numbers aren't in those projections. And then we get into trying to, so there's already a big enough problem in trying to train enough people to fill those positions. That's not even discussions on who's going to train the people who need to train the other people. So there's a whole other shortage there. And then we have this whole new technologies coming in, and it's not coming in slow. I mean, there's significant progress that's just, exponential growth. I was looking at a chart, I think it was yesterday, the day before, about, the development programs in electric propulsion, and it is an exponential curve up. And so we have a real problem. And so the FAA has helped us, as you've said, with the ACS. There's more avenues for getting the ACS updated more quickly than the old, Part 147, but it's still not quick. It just because they changed how to do it, that doesn't mean that, the culture and the conservativeness of the FAA has changed. So they're going to take their time in making changes, as well they should. Bad things happen when we don't, when airplanes go bad, right? So they have a need to be conservative, but in the meantime, how are we going to get technicians out there through a traditional 147 program? And I'm going to say, I'm not really sure we're going to have to come up with other avenues and new pathways and thinking outside of the box to meet not only the existing need, but the evolving and new need. So I think it's going to be a challenge.
Absolutely. Well, thank you for your thoughts on that, Tracy. And Stephen, would you like to
Yeah.
elaborate there a little bit?
Yeah, Zach, could you pull up? There you go. This is the opportunity, and this is also the concern. We have a rapidly, exponentially growing set of technologies in the aerospace market. Okay, if we look at FAR Part 147, Airman Certification Standard, it is a step in the right direction, and it's not my intent, nor is it our goal, to really beat up the FAA. We're not at all. What we're trying to do is to basically be partners with the FAA and also partners with industry, and to be able to say, look, technology is growing very, very quickly, and the speed at which technology is growing is outstripping our ability to effectively qualify the technicians to work on this advanced technology. It's no harder than that. So if we look at where emerging technologies are going, this is where some of the concern lies. When we've had the recent change to FAR Part 147, dropping Appendix B, C, and D, and moving to the Airman Certification Standard, it does give us the flexibility to be able to evolve and change the ACS to link in new technologies and new standards. But take a look at the slide. We're talking about advanced traditional fixed wing and rotary wing aircraft. We need to think about spacecraft. Whether they're type certificated or not doesn't matter. The reality is our airframe and power plant maintenance technician workforce is qualified and sought after highly by the spacecraft industry. So just because it's not a certificated aircraft, just because it's an aerospace vehicle that does not require an A&P certificate, the reality is an A&P certificated maintenance technician and avionics technicians are the most qualified persons to be able to work on that piece of equipment. In the future, we will be seeing hybrid electric and maybe even hydrogen fueled aircraft. Supersonic aircraft are now coming into the fold. Advanced air mobility is growing like gangbusters. There's nearly 400 aircraft that are currently under design, development, and certification testing under the moniker of advanced air mobility as we speak. Okay, this is a reality. If you look at thin haul and general aviation, electric conventional takeoff and landing aircraft, the aircraft that you see there is the eViation aircraft that is currently under flight testing. And then we have UAS. And then we have LUCA, large unmanned cargo aircraft. So these are aircraft technologies that are going to require some form of certification standard. So I'm very, very keen on finding ways that we can effectively partner with different organizations. The Federal Aviation Administration is one, and work together to develop new standards quickly, adaptively, and flexibly to be able to meet the demands for qualified technicians for the future. So my view is I don't want to beat up the FAA. They're our partner. And what we're here to do is to help supplement them and to engage them in a meaningful and productive way that can help us ensure that we have qualified technicians to work on these type of air vehicle and space vehicle systems.
Great. No, very, very in depth there. I appreciate your perspective on that. I think you're on the ball there with a lot of that stuff. Both of you are. It's been, quite just a deluge of technology, right? There's things changing all the time, and every time you turn around, there's new updated technology. It's kind of really cool in my mind. My background is the UAS side of the house, so it just really seemed like as things have progressed and UAS have been used more and more, it looks like a lot of that technology is actually being routed back to traditional manned aviation. As you look at these networks and the digital controllers, and a lot of these aircraft are fairly well flying software, right? Very, very software dependent, very computer and networking involved, to the point where you have organizations out there that have come up with some new certifications that are specific to some of these technologies, right? CompTIA was one of the ones that they're very big on computer hardware and networking. And the A&P license does not, the knowledge and stuff that's been a part of 147 and the ACS was very light on that type of stuff. So there's a lot of organizations out there that are really kind of stepping in. Some of them are aviation related, some of them aren't, right? So we've got this, this new technology that's coming out. We've already identified a shortfall in our existing A&P track, as far as, aviation maintenance technicians. And then you add to it this new technologies, as both Tracy and Stephen said, that gap and that shortcoming becomes larger and larger. So as we kind of look at that ACS and we look at the place that or the knowledge and skills that are maybe missing from some of that stuff. Stephen, you had mentioned EV. And Tracy, you had mentioned the UAS side of the house. And, I think we've got this mindset in aviation, or at least the way we do business, is that we've really been kind of stovepiping these things as different, right? We've got our traditional manned aviation that's kind of, GA, and then our big commercial carriers. But then we call UAS this kind of way different thing. And then we've got AAM, which is, a way different thing. And even talking, as Stephen did, about spacecraft, even though it moves through the atmosphere in much the same way, uses a lot of the same physics, maybe a little bit more powerful on the motors, but it's right. A lot of the technology and things like that, they're the same, and we've been doing unmanned spacecraft for years and years and years. But like I said, all these things, they're treated differently, but the technology is really merging together, quite a bit. And so, I think as an industry, we really need to address that. And so, how will we go about addressing this? Tracy, you mentioned that the FAA, they move a little bit slower, which is completely understandable, right? Their mandate is safety all day long. Right. And so they're going to take that, first and foremost. So where do we go? How do we find these bits and pieces that we need?
I don't think there's an I mean, it's an easy to say answer, it's harder to do. And so like the flippant answer is it's stuff like this. It's us talking, it's us looking at different industries. I mean, aviation's not the first to do electric propulsion. You've got cars that have been doing it. I mean, your Jeep Wranglers today can be hybrid electric vehicles, and that seems weird to me. Boats have been doing it. We have electric propulsion in boats as well, and it's just going to take people talking to one another and communicating. And then, you know, if I look at society, I'm like, we both like to silo ourselves, and then we also do like to communicate. We've got a fantastic communications tool in the internet for reaching out to people. If I want to find who is leading the way on electric propulsion in vehicles, I can find out who that person is. I can ask, I can ask Stephen, or I can go out on the internet and I can find, a Ken Mace, and I'm, hey, Ken, what's going on? Maybe we should have a conversation. And so we are going to have to talk to other people in these different areas and build those bridges, because excuse me, that is how we're going to solve, or at least try to solve, how we come up with this information and how we can pull it together. Because you're right, there's a core of that knowledge of UAS or electric propulsion or whatever we're talking, spacecraft, that is the same. There's a lot of overlap. This program here at Purdue does not train people for spacecraft programs. You know what? We still get hired at NASA and SpaceX, our graduates do. Why? Because so much of what they learn here is applicable there. And then they just take on that additional training, that specificity of, great, you've learned the basics of, physics in the atmosphere. You understand some propulsion stuff, you understand some avionics. You're 50% there, you're 60% there. Let's get you that 20-30% of the rest of the way. And that works for them better than trying to take someone off the street. So I think we as educators need to start finding those common areas, those core areas that are applicable to multiple applications, so we can better train our students. I mean, that's my thing, is how do we train students? I am an educator, my PhD's in education. That's where I'm like, okay, great, you guys have designed this. You've come up with some ideas what you need. How are we going to train these people? And it's going to take some communication.
Absolutely. I think you're spot on there with communication and reaching out to those other industries that kind of already did it, to not reinvent the wheel. And I think it's great that you mentioned a core between 147 and a lot of other things, and then kind of the autonomous technologies as well, because I know Stephen's going to speak on this one. So I'm going to go ahead and share this screen here, because I know this is one of the things near and dear to Stephen's heart there, based on some of the project work that we've been doing together.
Yeah, feeling the love. Can you pull in 8 real quick, Zach?
Pull in 8 first.
Eight first, yeah.
My apologies.
No, okay.
While you're doing that, Zach, Ernest asked in the Q&A whether or not we would share the slides with the group.
Yeah, so I think we can share some of the slides. Is there? Do y'all? Let's put it this way. Do y'all have any issues with sharing the slide deck?
No, not at all.
No.
Okay, perfect. Then what I'll do is I will, as we progress and get to the end and maybe a little more Q&A side, I will throw it up on Dropbox or something like that, and then throw the link in the chat, and that way folks can get it there.
So just very briefly, and I'm not going to give a full presentation here, but I do want to hit some key slides we presented at the University Aviation Association in Colorado Springs at the conference there. To answer your question, Zach, it's going to take a village to do this. Okay, we're going to have to formulate partnerships. What you see on the screen is just a taste of all the different stakeholders that are currently involved with anything defined as advanced air mobility. electric aircraft, UAS, whatever the case may be. All of these stakeholders have different points of view, perspectives, and priorities. But what we need to do, what's absent in a lot of this, is trying to pull all of them together and unify them in a meaningful way that will help us be able to advance the creation of infrastructure, to be able to advance technician qualification standards and requirements, and also credentials. Because I would challenge the industry right now to think that maybe, just maybe, the airframe and power plant maintenance technician certificate is insufficient to qualify a person to work on an electric aircraft. And one of the things that we've seen in a little bit of our research and also working with our industry partners is that the expectation is, the requirement will be, that that technician, before they're allowed to be able to touch and service and maintain the aircraft, they will very likely have to be certificated or qualified by the OEM to be able to work on that aircraft. So the industry already is starting to go down the path that the automotive industry is doing with regards to electric vehicles for cars. Ford Motor Company is going to require that you be credentialed under a Ford curriculum and standard to be able to work on their Ford cars in order to be able to maintain warranty. And there's also other OEMs that are thinking the same lines. So when you look at this slide, there's a whole list of number of people that have to be engaged and involved to help produce the qualification standards and also the certificates that are going to be expected to be able to work on these aircraft safely. Okay, so if you go to slide 10 real quick, Zach. This is going to require a process. You have slide 10.
Yes, sir.
Okay, on slide 10, you see the phases, phase 1 through 5. There it is. Okay. One of the things that we're proposing to do is to work in partnership with a variety of different agencies and stakeholders to be able to create a qualified technician. Well, first you have to identify what is the technology. The next step is you have to do an impact analysis. Then you have to develop standards. Then you have to develop a credential around those standards. And you have to ask the question, is the A&P certificate sufficient to be able to integrate it into the ACS to have a qualified technician? And you could argue the answer is, well, maybe. It depends. Not every school across the country is going to need an EV technician. Therefore, why put the burden of EV standards into a curriculum that their graduates are never going to use within their geographical domain, within their area? So we have to kind of think about that for the future. So then we need to develop credentials, potentially the addition of new credentials on top of the A&P certificate. And then we have to go out and develop curriculum and do training. So what does this then lead to? If you go to slide 22, Zach, what this then leads to is that a school is going to need to make a decision. How do I implement a new curriculum and new standards into a technician to qualify them to work in these aircraft? So if you look on the left-hand side, one of the models that we could follow is use 147 as a core and you plus up. So you have a 147 plus program. So you can, instead of thinking, oh, I need to integrate this into the existing curriculum, well, why not just go ahead and bolt on the curriculum onto 147 and just have the student take on some additional course loads to qualify to get that additional credential. So that's one model that you can look at. And the nice thing about this type of additive program, it's very flexible, and it also allows you to focus on localized workforce development. And if you go to 23, Zach, we'll actually look at a model of integration. As what was mentioned by Zach and also by Tracy, is that there's a tremendous amount of overlap in these standards. We get a lot of head nods when we talk to our colleagues in the automation and electrical technologies. I talk to mechatronics. We talk to advanced driver assist systems. We talk to colleagues in their EV. And what we find out is that there's a lot in common. There's a lot of language and principles and physics and technologies that we do share. So one of the models we can look at for deployment is don't reinvent the wheel, just simply make it additive. So if you look at the Part 147 standards and a standard, let's say like F46, just as one sample, or it could be NEVTEX, NEVTEX, the automotive EV standards that has been developed through an NSF grant, in which Ken Mays and Central Oregon Community College and Indian River NEVC, the National Electric Vehicle Consortium, have partnered together to develop these standards. Well, why not partner with them to develop standards for EV aircraft technicians? And if you look on the right side of the Venn diagram, just simply integrate those additional standards that are the gap between what is currently a standard within Part 147 and take the difference between the two and just simply integrate it in. So those are some of the models that we could look at. And so how can we adapt to the Part 147 Airman certification standard? You either integrate those standards or you simply bolt on the new standards in brief.
Yeah, that's great. And that's actually something that we've done here at Northland College for quite some time now. You know, we've had a large UAS maintenance program that we've been running since about 2010, since the original National Center for Aerospace and Transportation Technologies developed a standard for UAS maintenance technicians. That has since been taken over by ASTM. And in fact, there has been an update, and it should be published here in the near future. It has passed all its balloting and all that fun stuff. So we can look forward to ASTM putting that out soon. But that was our original idea with it, is we have a 147 course here. We've been training 147 since 1959 here at Northland College. So a long history of it. But you know, we identified this area that there was a gap, and again, part of that had to do with our region, right? We've got, you know, Northrop Grumman and General Atomics up here in the region. We've got North Dakota right across the river from us here, very heavily invested in UAS technology, and also one of the UAS test sites. And so, you know, we put this curriculum together, you know, through a development of a curriculum process, a DACM process, and we've been running it for quite some time with some really good results. But the idea is, it is a certificate that is bolted on to A&P. We require a student to either be in our A&P program or have an existing A&P license in order to be a part of that program, to graduate from that program. And yes, that's the idea, is that we know, as we talk about BVLOS and integration of larger UAS into our national airspace system, that the FAA isn't just going to wave it away and say that, oh yeah, that's some other thing, and we're not gonna, you know, we're not gonna require an A&P or any of those traditional pathways. I think that's a little silly if we thought that way. So we did the other way, and we said, hey, this is going to be an A&P. There is a safety mindset, and there's a safety culture that comes with being an A&P mechanic. And you know, integrating that in at the beginning is the way to go, as opposed to, you know, bad things happen, and you know, you don't have that safety culture, and then you've got to fight that the other way, which is a much bigger lift for folks. So I like the idea of that common standard and that common integration, and the integration to the standards. We have talked to quite a few folks, and you know, one of those pushbacks we get is, you know, we're already full. Our 147 curriculum is already full. So how do we integrate some of this stuff? And you know, Tracy, I think you talked about it a couple of times, but it's really not that big of a lift for a lot of these things, right?
No, and because that's, you gave me a perfect segue, because I did want to bring this up. The new Part 147 gave us another benefit, and that was removing the seat hours time. So I don't know about some of these other programs, but I know in our program, there are definitely some synergies that we can incorporate in our program to kind of claw back a little bit of the time that the previous 147 program did, that opens up some space. And this is why I personally like the bolt-on approach, because maybe I can, you know, the class I teach, you know, carburetors, propellers, and magnetos. Okay. In the previous program, you know, that was 4 credit hours that I did. And I had to, you know, fill up, you know, lectures 3 times a week, right? Under the new program, I can condense some things, focus on some other areas, and I can claw back a little bit of time. maybe it's a lecture or maybe it's 2 lectures during a semester, but that frees open some space to pull in some electric propulsion ideas if I want to, or some UAS stuff. And so I challenge any program to like look at what the FAA has given us as this gift with the new ACS and the ability to do competencies. I think you can find some time based on your local workforce needs. As you say, you've got a couple of companies that your graduates go to then go, okay, our program, I think we can, throughout our whole program, we can come up with, 20 hours over 2 years that we've got a new EV company in town and they want graduates. We can find time. I actually think that almost any program under the new FAA requirements can keep their core 147 program, evaluate it, look at it, find some time to, add in some coursework in electronics, some coursework in advanced avionics, in robotics, Metatronics, whatever that is, to help prepare them for the local workforce needs of that program.
Yeah, absolutely. I think that's absolutely great. And they do specifically, state in there that, the ACS is kind of your minimum, right? And
Right.
so you can feel free to add more stuff as necessary. So while I'm a firm believer there's room for updates in the ACS, with newer technologies, things like that. But I don't think that we've ever made in a Part 147 program. Our graduates aren't. I'd say they're not experts walking out the door, right?
No.
There's still more stuff to learn. There's aircraft specific stuff to learn, and maybe Boeing does one thing this way and another organization does it another way. So it's, every A&P instructor I've ever talked to has described the A&P certificate straight out of school is really a license to learn.
Right.
It gives you those foundational concepts that'll get you in the door to an organization, and then you'll really dig into whatever airframes and things that they specifically support, right?
Mhm.
And I think that's really the way we need to look at things, even with this new technology, where I don't think any of us are advocating that as soon as somebody comes out of an A&P school that has introduced EV technology, that they should be an expert in the field, right? But they should know enough to not walk out into the shop and touch things they shouldn't touch, right? Or if you do have to touch it, you know the proper safety procedures, at least the basics. So I think that's important to put out there, that we're not advocating to make these folks experts on this new stuff. It's bringing in a new project.
Right.
As we talk about propulsion projects, oh hey, we've got a reciprocating engine, and we've got a turbojet engine, and oh, right here we've got an electric motor or electric battery storage and production system. And so I don't think it has to be this huge overwhelming concept. But for those who have the time and want to do it, great, integrate the stuff in and get down into the nitty gritty. But for the rest of the folks, say, hey, this stuff exists. You're gonna see it. Our workforce that we're training, we're not training the workforce of 30 years ago or even the last 30 years. We have to look at the next 30 years and these folks coming out of school. And I think it'd be pretty accurate to say that, within a graduate, this coming year, within their career in aviation, they're going to see a lot of these technologies, and it's definitely gonna impact them and the way they do business. So, let's see here. Let me stop the share here and get back onto the page. Sorry, I'm trying to bring my notes back up. The one downside of having 3 screens is you've got 3 screens to go through.
Like, where did I leave it?
Yes, exactly. So, I know Steve touched on this a little bit, but how do we go about this? How do we go about making this happen? I know that you know, for instance, the AET, the Aircraft Electronics Technician certification that ASTM F46 put together there, you know, it's been recognized as kind of a means of compliance on the repairman side. You know, how do we go about getting the industry acceptance of some of these standards? I mean, do we, for instance, we'll talk about the electric vehicles and the electric cars. Okay, if we have an existing electric car standard and we get folks through and we strip out all things that are strictly car related, right? And so we're left with systems and architectures and things like that. But how do we go about getting those accepted by our industry peers and then the other academics, the other instructors at A&P schools? And then of course we've got to get them trained up on it as well, right? Steve, thoughts on that?
Yeah, I think we have to think differently. We do. I mean, just like universities have to think differently with regards to their place for educational delivery in light of the ability to be able to learn online. I think our industry has to take advantage of what we call technology convergence, the convergence of technologies. This is almost unprecedented in history, to where we can actually take multiple industries and we can actually coalesce them together to formulate a set of core competencies that could then be developed and grow into specializations. If you look at, there's two key technologies that I think of in which you have clearly opportunities for technology convergence. And one of those is you've got EV, electric vehicles, and then you also have autonomous technologies. We're currently working on a project with NCAT to develop knowledge, skills, and abilities, KSAs, to basically merge 5 different standards into a single common core standard. And yes, it can be done. And there's about what, Zach, 65 to 75% overlap, roughly.
Yeah, there's a huge overlap, and you know, I mean, especially as you look into you know, the electricity, pneumatics, hydraulics, physics, math. I mean, just kind of all over the board there. There's a lot in common.
Exactly. So imagine, if you will, if we take the systems on board these future aircraft, you've got satellite, you've got IT, as Zach was mentioning earlier, is these are basically flying software platforms. Well, that's no different than on the automotive side. I would dare say that the technology of advanced driver assist systems has a level of sensor technology and integration that is beyond the scope of current aircraft technology. So there's now a flip to where ground-based transportation technologies are actually highly more integrated, sophisticated, complicated than current aircraft sensor technologies. Okay, so there's lessons to be learned there. So there's an opportunity to create a technician that can go through a common core program. That's just on the autonomous side. If you bring in the electric vehicle side, when you look at the standards that are out there, like what was developed by Nevtex, okay, and also if you look at ASE level 3, which is the automotive service excellence standards for automotive technicians related to EV standards, L3. What you end up finding at is there's a tremendous amount in common with EV aircraft propulsion systems. So why not leverage that? Okay, and now when I talk to my colleagues at Utah Valley University and also other colleagues throughout the entire United States, their heads are nodding. They're saying, yes, you know, Steve, you're onto something here. There is a tremendous amount in commonality. Well, how can we leverage that commonality? Well, you create a set of standard core curriculum. Why not create synergies? Why not share resources? Why not share expertise? Allow a pipeline to occur to where you have a single point of contact or entry point that is, let's say, EV or autonomous vehicles, or maybe it's a common core across both of those. Why separate the two, right? And allow that student to come in, learn the core, complete that core curriculum, and then move into automotive, ground transportation, naval marine, UAS, aviation, right? Or mechatronics, automation and electrical technology, robotics. The reality is, because we share a common electron, The reality is because we share that common electron, we can create a common core. Now, how does that play into certification of technicians? It plays a lot. We have to stop thinking as being stovepipe. You're going to come into a program, you're going to be automotive. You're going to come into a program, you're going to be aviation. Well, you know what? The lines are getting blurred. Okay. And why not create a pathway, a career pathway for students to come in, learn, and as they're learning the basics through the core curriculum, allow them to be able to discern what direction they want to go to based upon the opportunities that are in front of them. And that allows regionally based decisions. It allows salary based decisions. This allows decisions to be made based upon personal interests. So my put to the industry, to the Aviation Technician Education Council, to ATEC, to ASTM, okay, and to all the alphabet soup of standards that are out there, let us work together in concert to create these type of common opportunities, to leverage those common core standards, to enhance our ability to create qualified technicians for the workforce. Me personally, even though I'm in aviation and I'm biased towards aviation, I don't care where you go. What I care about is that we have a qualified workforce that can work on these advanced technologies. So let's work together hand in hand. Okay, and let's think outside of the box, considering the realities of where we're currently at with current regulations. Okay, I got that, but let's not talk about it just because it's difficult. Now's the time to do it. And so how do we integrate? We do it right now. We create workshops, we define common curriculum and core, we go back to our industry base, we get feedback from industry, we get their support, we talk to credentialing bodies like could be CertTech, could be Space Tech, could be the FAA, could be SAE with the EV Pro Plus certification standard. We have to think more globally. We have to think more in an integrated fashion. We need to get everybody into a room together and share and talk and leverage each other's capabilities to create that qualified technician.
Yeah, absolutely. And I see the same thing, at the colleges that I visited and even Northland here in some places, where we've got, a precision ag program and an automotive and an aviation and an electronic technology. And, there is a lot of overlap between those programs. And so it would be more efficient to pull out some of this core and present it in that manner. And I think maybe it might open up some more interest for folks, knowing that they can come in and they can learn this core and it can be applied to many different places. So they don't have to know what they want to work on, as they leave school or even as they finish school. But they know that, hey, I want to do something that's a little more hands-on and gets me into the shop, and I'm not just being, lectured to, things like that. And so maybe you go for this core, whatever it's called, right? And then from there you can pick and choose what you want to do. So you have this core and you go, I want to just be able to fix my own car and maybe work at the local shop. Cool, you head off in that direction. Or maybe you decide to go heavy equipment or aviation, unmanned systems. And so, I mean, there's a lot of different ways you can go, even into the maritime systems, right? So I agree with that kind of wholeheartedly, that's really the way that a lot of us should be moving. And especially as you look at, I mean, lack of teachers, not having, qualified teachers to teach all these different programs, or the qualified teachers you do have are just swamped. They're overloaded with credits because they're the ones sustaining their programs. And so if you could bring in one person to kind of teach some of that core, it frees them up to be able to go more in depth in their specific area. So of course the resource allocation is a big thing. Not to mention the funding aspect of it, right? We're all in higher education, and funding, especially, state allocated funding, has been dwindling over the years. And so finding ways to make up for that is, those synergies, those places that we can merge things together and make some financial and logical sense as far as the career pathway goes. So absolutely, I'm going to stop the share here. And all right, so at this point, I'd just like to thank you both for for dealing with me, putting up with me, and coming and being a part of this. And I'd like to thank the audience as well for coming out. Is there any last thoughts on the subject, and then we can open up to Q&A from the attendees if you've got any questions, and we'll start. Tracy, Steve. All
Let's
right.
hear the questions.
Tracy, do you want to go first? I just have one comment that'll last like 15 to 20 seconds.
No, go for it.
Yeah, I'm going to challenge the group here. And I'm going to reach out a little bit and dare say that we're entering a time to where I no longer have to be focused just on aviation as a technician. If I decide I want to go automotive, I will be able to. I want to go naval marine and do autonomous naval vessels and submarines. I'm going to go do that. We're now at a point in time to where people can gain additional credentials and have a skill set that is transferable across a variety of not only aerospace industry segments, but across a variety of industries, whether it be automotive, and I'll dare say nuclear, whether it be alternative energy sources, whatever the case may be. You're going to start ending up having a highly qualified technician workforce that has a transferable skill set and set of credentials that will be able to move. Now, we have to be prepared for that, because the industry is going to have to realize that, wait a minute, I have a very fluid, flexible labor market, and I'm going to have to compete for that labor market. And we would be very wise as educational institutions to adapt our programs to meet that inevitability. And in fact, I think we can actually drive that inevitability. We don't have to. The national average is that an individual will change their career title 8 to 9 times throughout their career. That's just a statistical fact. Okay. Now, most of the time that stays within one career pathway, one industry. I dare say that those 8 to 9 job changes within an average career could actually bounce between automotive, could be nuclear, could be alternative energy, could be aviation, could be space. And so I think my recommendation would be, and I challenge this group who's listening, is to let's work together, let's think differently, let's challenge the system that's out there and try to find new ways to create pathways to educate and train and create a qualified technician workforce. So sorry, that was more than 15 or 20 seconds. I lied. I became a professor there. Sorry.
Yeah, no worries. So if there's anybody in the audience that has any questions, again, you can write them, raise your hand, whichever works for you. And let's see, we see Mr. Mays there. Mr. Mays, I see your hand up, so we'll let you chat if you want to unmute.
Thank you, everybody. And Tracy and Stephen, good job today. And really already has created a set of processes here in place. So good job. And I would love to be a part of this conversation and excited for this. I've just, Tracy, you were talking about introducing 20 hours into a current program, and that's a good way to start. But I do think that dedicated degrees towards this will be ultimately developed. Once you get the governing standards in place, you'll appreciate what is going to be required. So if you're going to do 3-phase analysis on an electric motor, you've got to be able to have that standard. It's a standards-based process. If you're going to do a stress test on high voltage batteries, there's standards for that have developed all that. So those are just a few of many examples of that. And the NEVTech standards do include the fuel cell as well. So there are 8 categories on fuel cell. Whenever somebody wants to grab those, I look forward to meeting at some location that you designate, Zach, that you want to pull people in to start doing some analysis. I don't know if it's a 1-day or a 2-day, but let's bring some people who have a long history of developing engineering and helping this process. So we've talked about that, and I'd like to be a part of that process.
Absolutely, Ken. And just for clarity, yeah, there's going to be specialists that dive in depth in all these things. And again, I think that when you get out onto a job site or work with an organization that supports a lot of this stuff, there's still going to be in-house on the job training. So yeah, absolutely. And I think the standards that exist for even some of those individual tests and performance metrics, I think they're still viable, and there's still going to be a need for them. Absolutely. So even that in-depth stuff. But if we can just start introducing this technology and providing those functional building blocks, at the school, it takes some of that pressure off the employers, right? They don't have to go as in depth. You already have, you at least the terminology and kind of what things look like. So it's a step in the right direction. So, and then Ken, of course, we're gonna reach out and have some conversation. All right. All right. I don't see any other hands up at this point. I'll
The Mark Quarto I messed up his last name and something in the Q&A.
yes. So okay, in the Q&A here, Mark says that agrees with Stephen that collaboration will be key. As part of NEBTech development that resulted in the global EV certification program, that EV Pro Plus that Stephen had mentioned. He thinks that there's significant elements of the certification that can be used in aviation propulsion, and that it would accelerate curriculum and education program development. And I think, Dr. Corto, you're right on the ball there. So love to see folks that are out there that think that what we're saying makes sense. That's always a good validation to have, right? Sometimes we get into these little groups where we start talking to ourselves in circles a little bit, and so it's nice to hear some outside perspective that we may be somewhat on the right track. So thank you.
Yeah, I think to that point, Dr. Porto, is we're already bending the ear of ASTM. We're bending the ear of ATEC, Aviation Technician Education Council. And so I think there's opportunities there by people like Tracy, myself, Zach, and others that are participating in multiple committees within these standards organizations. I think can be very, very key in making sure that there's a voice to try to create this connective tissue amongst the different organizations. So that way we don't reinvent the wheel. And I've seen that because groups or agencies are stovepiped. What ends up happening is they end up creating their own standard outside of any experience that others have had that have already produced a standard. So if we can help connect the dots and build relationships amongst these different organizations, we as a whole are going to be far, far stronger in having a voice, and we're going to have a better set of standards out there as a result. So thank you for your input.
Absolutely. All right. So, all right, at this point, I'm going to go ahead and stop the recording.